you are welcome here in the fourth part of the video of the current electricity. Okay, so we have learned about the voltage, potential difference and the concept of the current, and also we discussed about the resistance, right? So here we know that when a potential difference is maintained across a conductor, a current flow through the conductors, okay, I, and suppose the potential difference applied across this conductor is V, right? In 1826, a German scientist named George Simon Ohm, okay, find a relation between the current and potential difference, and according to his law, a current flowing in a conductor is directly proportional to the potential difference across its end, provided that the temperature of the conductor is constant and other physical conditions are constant, right? This law is known very popularly as Ohm's law, right? Just after the name of the scientist, okay, as the name of the scientist title was Ohm, this law is known popularly as Ohm's law, right? Suppose I told the current flowing through the conductor is I and potential difference is V, then according to Ohm's law, what it is? It is I proportional to V, right? That means we can also write V proportional I, or V by I is always constant. This become equal to always constant, right? And this constant we say as resistance, and it is designated by letter R. That means V by I equal to R, okay? This is the relations developed by the George Simon Ohm, okay? That means it can also be written like this: V equal to IR, right? If the current flowing through the conductor, that means I equal to 1 ampere, then V becomes equal to R. That means the resistance become equals to the value of potential difference, right? So what is the unit of resistance? So R equal to V by I, which is equal to volt ampere inverse, right, to the power minus 1. This is the unit of resistance, which is known as ohm. We say this unit technically as ohm, and we write this with this symbol also, okay? So we can also write it like this: volt ampere minus 1, okay? This symbol is known as omega, okay? And we symbolize resistance with this symbol, okay? We notice in many electrical drawings, right? So what is 1 ohm? If you want to define 1 ohm, then we can say when 1 volt of potential difference is maintained across a conductor and 1 ampere of current flow, then this becomes equal to 1 ohm of resistance, right? Ohm is the basic unit of a resistance. We also know the bigger unit of the resistance is kilo ohm, right, or mega ohm. Kilo means 10 to the power 3 ohms, and mega means 10 to the power 6 ohms, right? And the smaller unit are milli ohm, okay, micro ohm, micro equal to 10 to the power minus 6 ohm, and milli ohm equal to 10 to the power minus 3 ohm, okay? Ohm's law doesn't remain valid if the temperature doesn't remain constant, right? So Ohm's law is valid only at constant temperature. Okay, right? Here I want to show an experiment for Ohm's law. Okay, to verify Ohm's law we can perform an experiment. I am showing like this. Suppose I want to take the reading of current and voltage across the resistor. That means I will plot the graph of the current and voltage across this resistance. Then what will I do? We will connect a voltage source to maintain a current across this conductor. Thereafter we connect a variable resistor which is represented with this symbol. It is also called rheostat, and we will connect a switch in series like this. It is called a push switch. Okay, after that we will connect an ammeter to get the current reading, and also we will connect a voltmeter across this resistor to get the reading of potential drop, that means IR drop across this resistor. Okay, and I will complete this circuit like this, right? So this is the voltage source, right? Here I will change the current which is flowing across this resistor. That means it is suppose I ampere, and the potential drop, that means IR, which is volt, will be recorded by the voltmeter, right? So we will change the variable resistors one by one, and we will take the 4 or 5 readings and we will plot on the curve. Suppose this is the curve I want to plot, and I will make a table like this. Okay. VI. We will keep the resisted value at one particular point, and we will take this reading and this ammeter reading. Okay, this reading and this reading. Similarly we will take 4 or 5 readings, and if we will plot here, we will get a here straight line. Okay, and which will give the characters of the resistors, and it is evident that it is an ohmic resistor. That means it is obeying the Ohm's law, right? And if we change the temperature, then what type of the curve we will get? Suppose I am again drawing that curve, and here suppose that T1 and T2. I want to plot the curve at 2 temperature, and T1 is greater than T2, right? So at the T1, which is greater temperature, the resistor value will be more. The more resistors value, that means will be IR drop will be more. That means potential difference for the T1 temperature will be more, and due to this, the curve if I draw here, you will get this type of the curve. Okay, suppose the distance will not be like this. This will depend on the temperature. This is for the T2 temperature, this is for T1 temperature. If any reading I want to take for the same resistor, okay, for T2 temperature, the value of the resistance will be less, because V by the current I will give a less value, and here the resistor value will be more due to the increased temperature of that resistor at this condition. Okay, so the higher temperature slope will be above the lower temperature slope. Okay, next I want to show a non-ohmic slope, right? Suppose if a current is flowing across a diode, then we will get this type of the curve. Okay, so it is because the diode do not follow the Ohm's law. Okay, so they are called non-ohmic resistor. Their resistance is called non-ohmic, right? Suppose I am showing the VI curve of a diode, right? This is the origin and this one is the curve. Okay, this is not a straight line as it is not following the Ohm's law. To find the resistance of a particular point, suppose this is the curve to find the resistance of a particular point, suppose at this point, what will I do? I will draw a tangent, okay, like this. I will draw a tangent at this point, okay, and the value can be determined by finding the slope of this tangent, okay. So what will I do? I will find the first value of V1, suppose this is V1, and at this point suppose this is V2. Similarly this is I1 and this is I2, okay, and this is the changed value, we can say is del V, and this one is the del I, right? So to find the slope of this tangent, we can do like this: del V by del I is the slope of the tangent, and this is called the dynamic resistance, okay. Dynamic resistance. Why I am telling dynamic resistance? Because the resistance is not constant, because I told in Ohm's law that the relationship of voltage and current is a straight line, okay, and it remains constant at a particular temperature, and that constant is called resistance. But I am watching here, the value of the resistance is not fixed, not constant, it is changing. That's why we are telling dynamic resistance, okay.